nature's most amazing creations. Every day they glide around us, effortlessly carrying birds on the wind. Yet the origin of feathers has always been a mystery. An evolutionary puzzle that has driven scientific passions for more than a century. How did these marvels of natural engineering evolve? The answer lies hidden in their dazzling design and in fossils from the ancient past. In the last few years, new fossils have been unearthed, shedding light on the feather's elusive origins. Fossil dinosaurs covered with feathers. Could dinosaurs have been the first to be covered with this incredible innovation? How did they use them? Is it possible that dinosaurs could fly? To answer these questions, scientists from many fields are working together, employing the latest research techniques to unlock the feather's surprising history. Suddenly, the mysterious origin of the feather is now coming into focus, and the astonishing answer will change your definition of feathers, birds, and dinosaurs. Rick Prum's lifelong fascination with birds eventually became focused on the one feature that set them apart from all other animals, their feathers. His obsession with their hidden history resulted in an entirely new theory of feather evolution.
A lot of the most amazing things about birds are consequences of the fact that they have feathers. So they have beautiful plumages that we use to recognize birds. They have a coat of feathers that allows them to stay warm on cold days like today. And obviously, they use their feathers to fly. And these are all aspects of avian biology that make birds particularly fascinating.
In the last 20 years, biologists have shown that birds are the only living descendants of a long line of fierce predatory dinosaurs. Yet this impressive genealogy has failed to explain when, why, or where feathers first appeared. Like a detective on a cold case, Rick hoped a fresh look at the evidence would reveal something new.
I was dissatisfied with the classic theory of how feathers evolved, and I realized that some of the critical elements to a new story, a new hypothesis for how feathers evolve, could come from how feathers grow. Hidden within the details of how feathers grow were clues as to how feathers evolved, clues that would unlock their evolutionary history.
While Rick searched for clues in the lab, half a world away in Liaoning, China, paleontologists were searching for clues written in stone. The fossils they found revolutionized the field. Here were dinosaurs with feathers, or something like feathers, covering their skin. Liaoning allowed scientists to peer through a window into the past to a time 128 million years ago when dinosaurs ruled the Earth. To discover how and why feathers evolved, Rick sought out scientists whose passion to answer the question matched his own.
And just like humans are primates, birds to me have always been dinosaurs.
And we're having to rethink everything about birds.
And it's a very different thing when you realize that dinosaurs are not extinct, that there's in fact 10,000 living species of dinosaurs today, which are birds, but they're also dinosaurs.
Feathers present an extraordinary evolutionary puzzle. Following the clues left by feathered dinosaurs is made more difficult by the astounding diversity of feather form and function. Feathers come in many shapes, sizes, and colors that perform an array of duties. They are lightweight yet strong, flexible yet resilient. From tufts of down that provide warmth to sleek flight feathers that create the streamlined wing. An amazing palette of colors and patterns help birds hide from predators or advertise for mates. It is hard to imagine all the things that feathers can do until you see them in action. Rick gets up close and personal with a rough-legged hawk, or should we say a rough-legged dinosaur.
I got some arteries down there. The body of the bird is covered with contour feathers. The contour feathers form the outside, the outline of the bird, and are the primary protection from rain and from elements, and also create a lot of the plumage patches that allow us to identify the bird as a rough-legged hawk. The bottom parts, the base of many of the contour feathers, are downy to provide additional insulation. Now, on the wings and tail, we have flight feathers. And these flight feathers are asymmetrical in shape. The leading edge is narrower than the trailing edge. These flight feathers provide the aerodynamic forces that allow the birds to fly.
It is the delicate airfoil design of the flight feathers and the aerodynamic forces they create which allow lift and keeps birds airborne. A deceptively simple and elegant design with spectacular results. The amazing diversity of the feather is built on a simple idea. Feathers are branch structures like trees. The way their branches are shaped and work together is a marvel of microscopic engineering, as delicate as it is effective.
So feathers are branch structures. The main shaft going up the center of the feather is called the rachis. Connected to the rachis are numerous smaller branches called barbs, and connected to the barbs are even smaller, nearly microscopic branches called barbules. Together, these small filaments interact to create the flat, planar surface of the feather, which is called the vane. A feather that has a complete vane is often called pennaceous. The flat, planar vane of a pennaceous feather is formed by the zippering interaction of the barbules from adjacent barbs. The barbules in the pennaceous feather function a lot like Velcro. Interlocking together, they create a surface that is strong and resilient and that can withstand the forces of flight.
Although the microscopic design of feathers provides many advantages to the lives of birds, this hidden complexity makes it even harder to explain how feathers evolved. The answer to the mystery of feather origins lies in fossils from the ancient past and locked within the feather itself.